going to very quickly talk about some of the technologies. What are the critical technologies that we need and why do we need them? Plastic electronics is actually catching on big time in the UK. You say, why do I need that? Well, if you want sensors everywhere and you want computer processing everywhere, this is a very cheap way of delivering very low-cost sensors and very adaptable processing at very low prices. And if we're going to have what some Americans call smart dust, which are connected sensors, then you need this sort of material. Composite materials allow you to make lightweight vehicles. The aviation industry has been doing it for ages. We're now looking at how we use composite materials in all sorts of other structures that are to do with mobility, because the last thing you want to do in transport is move mass around unnecessarily. Embedded connectivity, wireless everywhere, but also fiber optics wherever you can get it to give high bandwidth and good visualization. We need to make those systems adaptive, and we need new ways of sensing things. There are new parameters that we need to understand, that we perhaps don't have sensing technology that's affordable to deal with it. And we're going to do this at scale. A lot of this we've not done at scale for a long time, so we don't really know how to do these sorts of things except in certain niche areas. It tends to be consumer markets that know how to do things at scale, so I think we can learn from that. And how do we avoid lock-in? Because a lot of infrastructure, particularly the civil engineering end of the markets, tend to lock you in, because once you've built a bridge or a road, motorway or a railway line, as I displayed earlier, you're locked into it for tens, if not hundreds of years, and it's quite difficult to get yourself away from that. I'm going to distinguish very deliberately between technology research and engineering research, because I think we need to engineer solutions to modernisation that delivers concurrently all of these factors: resilience, low carbon, socially acceptable, economic performance and service quality, emphasised concurrently. You could optimise on any of those individually relatively easily, optimising across the lot at whatever scale is appropriate. And can we do it at the scale we need to and at the rate we need to? I think engineers need to think about that. I think there's a piece of engineering research that is quite interesting. And can we learn from the way other people are doing this? And again, I'm going to distinguish between engineering and design, which brings me to the social acceptability of the solutions. The attitude to infrastructure is very much habitual. We tend to do tomorrow what we did yesterday. Can we change people's habits about what we would prefer them to do? We collectively, we government, we leadership, we the market, by good design. And we all know that certain things in the market, of course, has to behave differently, because very smart marketing people and design people have got their heads around things, and we now accept things to be different from how they were. But is that in the interest in infrastructure? To have infrastructure designers got their head around that sort of metaphor? I'm not sure we have. And in particular, we've grown up to be a very consumption-driven society. But we've now got to understand much better how we do conservation, because we're beginning to see what the limits are on a number of our natural resources, whether it's land or fossil fuels or anything else. And understanding how society works in that regard is a design issue, social design maybe. And does that mean a more effective collaboration? Because competition is a pretty blunt weapon. It's a pretty blunt tool for achieving conservation, because it really doesn't. It tends to accelerate consumption. And the media have a really significant role in all of this, because they influence our opinions. We have a program on television, I don't know whether you get it, called Top Gear. How much does that influence what you think about motoring? Because we've discovered it influences our population in the UK more than anything else. And most of you know that Top Gear isn't actually about mainstream motoring. It's about sort of the exciting end of the market. And then interdependency research. I'm afraid this picture is another picture of our flooding in Gloucestershire of that particular year. ICT and energy, in the analysis we've done so far, we have discovered to be the particularly critical system of systems metaphor. But we've also discovered that actually water, waste and transport are not very far behind. And you add all five together, you've got a really complex system of systems to understand. We've only just started thinking about how to do analysis on that interdependency, because they're largely under-regulated, and they're a matter of bilateral contracts, which are usually invisible to regulators, even to investors. They're just sort of made to work until they don't, and then you find out that actually it's a rather critical part of your system. And that means we need to understand system of systems analysis and the operational management disciplines. I discovered at the end of the Second World War that civil service in the UK was largely populated by engineers and by operational analysts. Almost no economists. Now it's exactly the other way around. It's absolutely stacked full of economists, and there aren't many operational analysts and engineers. Certain sectors, of course, there are, but across the piece. And then we have this euphemistic word called generalist. You can leave the rest to your imagination. This is where we've got to, and I'm sorry this is really busy. Actually, that's not too illegible. I thought it might be worse. So down the left-hand side, which you can't quite see, I'm sorry, is a list of various assets that might exist in transport. So it goes through things like roads, cycling paths, airports, seaports, control systems, oil distribution networks. Sorry, I'm just picking on a few. And then across the top, we've got their dependency on, and you can read those other sectors. And each matrix element has a letter on it, which is high, medium, and low, which says we're very worried. And the really red ones, where we're really, really worried. There aren't many, thank heavens. So what this is doing is, and we've got a whole family of these, all both ways round, so that we can see where it is we should prioritise our thinking, both in terms of research and otherwise. And I hope some of those, when you look at them and think about them, say, yep, we've got that, we've got that, we've got that, because I can't believe they're going to be very different. Now this piece of work is in a report called Engineering the Future, Adaptation to Climate Change, and at the moment it's about adaptation to extreme weather. It's not the only thing we're going to do, but we started somewhere, so we've looked at that. And I've given copies of that report to you. It is downloadable from the Royal Academy of Engineering website, who we got to do this work for free, because the engineers saw if they got this information, they had markets they could get into. So how was that for intellectual input, intellectual investment without any money changing hands? That was really rather pleasing. So I'll leave that with you as just one example of a bunch of matrices. That's one way of looking at it, but it's a rather databasey way of looking at it. It's a rather two-dimensional way of looking at it. This will frighten you. This is one set of a whole range of diagrams. I think there are 28 diagrams like this, where we looked at all the infrastructural components. And sorry for this one is the one that's most acronym-free. This is the energy infrastructure electricity supply side graph, which shows fossil fuels, renewables, generation, and all the other players. And the arrows, of course, are the important bit. You'll mostly recognise what the blobs are, but the interdependency between the blobs varies between something that is regulated for safety reasons and something that is there because that's how it is made to work. But how vulnerable is that? Not only to what's going on within that element of the diagram, but to what the policy and standards and what the demand looks like. And this is just energy, electricity. There's another one for oil and gas and another one for fossil fuels. And then there's a whole other set for transport and a whole other set for water and waste and ICT, which is why there's 27 of them. And we've got this information derived from talking to experts in all these domains. And now we're thinking about what we do with it. But the crucial thing is we have not understood at all how rich this set of interdependencies is and how to prioritise them. So these two sets of work together are beginning to come to a situation where we understand better what to do. And that will allow us to do some optimization across a whole range of different spaces of academic research and analysis, and then delivery of thinking into solutions for people to consider across the transport, energy, ICT, water and waste domains. And you'll recognise, especially the academics in the room, will recognise faculties that have those sorts of titles attached to them. But the interesting space is the one in the middle for us. And of course we don't reward people to think about and act and deliver in that space in the middle, but that's what society needs if they're going to manage infrastructure in a sensible place. So we are working at trying to reward a relatively small group in that area. So just to finish, I thought I'd leave you with some exam questions. And the metaphor of an iceberg is actually quite interesting, I think, for infrastructure, because most of what we really worry about is below the water, because we really only know about it when we hit it. We have to improve, in the UK at least, a culture that values the modernisation of national infrastructure. Because if you don't value it, you're not going to invest any form of capital in it. And I sense that actually in Australia, from what I've heard, you have a better position than we have in that regard. So I'd be very intrigued to know, either historically or whether politically you managed to drive that agenda to where it is. I think we do need to promote international collaboration on infrastructure research. It's not only a niche subject, it's a vitally important niche subject, but it touches almost every other discipline out there. Have we got enough STEM professionals to do the work? No, so we have quite a big education program, but I'd be interested to know how you're mounting the business case for that. And we have, as I sort of indicated earlier, this issue of how to get the right balance between energy security, there's other words there. They all need to stay in balance going forward, and we need to find a way in which discourse about that can happen. And then what should government do? Should government get out of the way? Should it get in the way? At what scale should it do that? And listening to the debate earlier, there is an issue, obviously, in this country. It certainly is true in our country, at what scale it is appropriate to do that. So for us, we're facing this issue. Oh, sorry, and then very importantly, what's the do-nothing option look like? You know, do we just subside into becoming a country no one wants to live in? And if we don't, what's the right sort of balance between investment in infrastructure and not? So we think we're somewhere in this sort of position. And that's not an acceptable position to be in, mainly because what we're leaving for the generations into the future is something that is aging and getting worse. And the intergenerational equity, which is a very fashionable political phrase in the UK at the moment, I'm sure it's propagating around the world like wildfire, is now beginning to get into the debate about infrastructure. How do we make it adaptable, resilient and effective, and at the same time make it fit for the future? The elephants in the room, as far as I'm concerned, are governance, collaboration, finance. It's a planetary scale problem that we've got to deal with in a locally optimized way, because if we don't all play at it in a joined up way across some of the agenda items, we'll be in a mess. I think SMART is a marvellous initiative to develop a place where research around this agenda can be constructed, and personally I'd be delighted to help make it a success in whatever way I can. Thank you very much.